In this video, I'm going to talk about conceptual understanding and what and how you can use this in your classroom, specifically focused on math. I think math is maybe the hardest subject to teach for conceptual understanding, so I want to dive into that. Now, a couple of years ago, I was really searching for meaning in teaching math. I was trying to figure out how we could make it and how I could make it more meaningful for students because I just felt like students weren't engaged. It didn't matter to them. And I really had to question, does it matter to me? And once I landed on, I can actually teach for conceptual understanding, this stuff does make sense. How can I start teaching that way? I stumbled upon conceptual understanding and it totally changed the game. So I want to give you an example of traditionally how a typical section in Algebra 1, like on solving equations, that's a pretty normal chapter unit, is solving equations, something that we just expect students to be able to do at the end of Algebra 1. Now, normally what I've seen and how I am guilty of teaching as well is I would try to give students a prescription for how to solve it. Like, okay, you see these signs, you can do this. Here's things that you can try, see if it works. The other things I've seen, inverse order of operations, which I think is tremendously confusing for students. It's like, okay, here's the order of operations. Now let's do the opposite of that. That doesn't make sense. It didn't make sense to me as a student either. Other things is you just do it. You just try something. You just go for it. And students don't really know where to start. And then the one that I hear all the time, and students will say, oh, the goal of this is to get X by itself. I think if we teach it using these methods, there is just such a better way. There's a better way that clicks, it makes sense, and it's for understanding. And it's not just some blind process or some prescription or some method. We're missing a huge opportunity to actually talk about really meaningful things for students. And so this is where if we take a conceptual approach, instead of saying we're going to solve equations, what if we focused on understanding equations, solutions, and equality? Equality is one of those words that students come in knowing something about. That is one of our concepts. So whenever I look at this unit, concepts are things that can be understood. They're also things that can be transferred to other contexts. So either within the math world or outside of the math classroom, these things show up. So these are an example of different concepts that we would want students to understand and have deep understanding of so that they could transfer it elsewhere. So equality, what does that mean? What do they come in knowing about equality? And then how does math use the idea of equality and equations to help further their understanding? And so that they can apply that new understanding or that more profound, different perspective of understanding on equality elsewhere. The idea of solution. Solution is something that when you substitute it in, it makes it true or it makes it work. And so that idea is also paramount in algebra, and it's really outside of math as well. Manipulate. What does it mean to manipulate? The equal sign. What does the equal sign actually mean? What does it indicate? When we're talking about the equal sign, we can talk about coding and computer science and how these two items are the same. They can be used interchangeably. And defining what variables are. Variables was another one that I did not include on this list, but variables, things that can change versus constants that can never change. So we're talking now about science as well. We're interweaving, getting a STEM idea here of, what are things that are always constant? Why is pi always constant? Just things like this. Why is it constantly the same value? What does equivalence mean? How do we preserve equality? And so when we start thinking about this a little bit different, for me, this added meaning as a teacher. And for students, it added value to what we were actually doing. And it didn't just seem like some blind process that some people were good at, some people weren't. These were accessible to everyone. Everyone can understand these. And if students can understand these, then the process starts falling into place and it starts making more sense. What I found is I used to teach for conceptual understanding. It was this much. And that was my version of teaching for conceptual understanding. I didn't assess for it, but then once I started adding in this much, kids actually started understanding it. They started getting it. And then I'd start assessing it, and I'd start asking them, like, hey, what does this mean? What does equality mean? How does equality apply here? Manipulating, preserving equality, all these things, how does that apply? And when I started asking and assessing and making that a focus, students started understanding that much more, which led to this process. And we spent much shorter amount of time on the process of solving equations because we had foundational understandings of what solutions meant and how to preserve equality through these operations, what the equal sign, how that played in, that we actually spent less time and students did better in terms of understanding it. So a few benefits that I've seen: it makes sense to students. Students understand these things. It's accessible to students. All students can access this material. And the third one is, it wasn't just a set of blind processes or things that we were completing without meaning. Now it actually made sense to students of why we can do certain things and why we can't. And then how, again, like the last thing is, how can we take these ideas and transfer them outside a math classroom? Because if we're only teaching math for either the next subject or the next chapter, we are missing a tremendous opportunity to add meaning to our discipline. So thanks for joining in. I hope that you can find a way to add in more conceptual understanding, because students deserve it and it will add value to your craft as well.